This
everyone, right?
conference will now be recorded.
So let's get started from the previous session, right? So like yesterday, we understood the concept of like big data, right? So we started with introduction to big data. Then we understood the concept of like what is big data versus what is Hadoop, right? So like I explained, right? There is no technology like big data. Big data is just a terminology, but the actual technology that people are using for solving big data problem is what? Hadoop, right? Then we define big data with the help of 5 V's, that is your volume, velocity, variety, value, and veracity, right? So volume is nothing but the size of data, velocity is speed, variety is type, value is the importance, and veracity is the change in data. Then we understand the concept of problems with big data, right? So what are the major problems that people are facing with big data? So there are two major challenges that people are facing. One is the storage problem and another one is the processing problem. And then we understood like why big data suddenly came into picture, right? From last 8 to 10 years only, why it was not there before. So the major reason behind big data was like the lots of small devices, as well as the internet connectivity to that, because we are widely using social media application nowadays, using our smartphone. We are using WhatsApp, we are using Facebook. Also we are using these online shopping portal like Amazon, Flipkart, Walmart, right? So all those components are, or you can say all those apps are the major reason behind generating this much amount of data. And like I stated earlier, right, data is the main business for each and every company right now, right? So they want to get as much data about you as they can, right? They want to analyze your data. They want to come up with some conclusion out of whatever data they are getting from your mobile device, and then they want to sell their analytics to the company, from which the company is getting some competitive advantage, and the company who is doing analytics is making money out of your data, right? So that was about what we discussed yesterday, right? Today we'll be starting with the concept of the existing system available in the market, right? So before big data came into picture, right? So, or you can, before Hadoop came into picture, right? Which are the existing system available in the market, or which were the existing systems available in the market, right? So we are using computers since ages, right? And it's not like if big data was not there, we were not developing any kind of softwares, we are not doing analytics, right? So we were developing softwares, we were doing analytics, we were storing data, right? So which were the existing system that we were using for storing and processing our data, right? So the first most is the, you can say, the local file system, right? Or you can call it the LFS, right? So before big data came into picture, right, we had the concept of LFS. LFS is nothing but your local file system, where people will be storing their data locally, and then they will be processing their data locally, right? We'll be understanding the drawbacks of each and every drawbacks of each and every existing system, right? Why they could not survive long term in the market. We'll be understanding those in detail, right? But first I'll just list down the existing system available in the market. So the first is the local file system. Next, you can call it the distributed file system, or you can call it, let's the DFS, right? Third one is the RDBMS, that is your relational database management system, or you can simply call it your SQL database, right? Right. And the fourth one is the NoSQL, right? So NoSQL, the full form of the NoSQL is not only SQL, right? So we'll be understanding the drawbacks of each and every system, what exactly is the meaning of each and every system that were available before Hadoop, and what are the drawbacks of those systems. Why Hadoop came into picture, right? Because of whatever drawbacks were there in this existing system, it was required for Hadoop to come into picture to solve the existing problem available in the market, right? So let's get started with the local file system, right? So what is local file system? So local file system is nothing but, let's say you have one computer, or you have one laptop, right? Or you have some local server available in your company, right? So whenever you are storing your data in your local machine, right, so you can say the storage will be in your local, right, as well as the processing will also be in your local machine, right? So whenever you are storing your data into your local machine, as well as whenever you are processing your data into within your local machine, right, then that file system is called as what? Local file system, right? Now what are the drawbacks of local file system? So the first most drawback is like, so let's say you want to store all your data in your laptop, or you want to store all your data in your single computer that you are having, right? So the first most drawback is like you have limited storage space available, right? So let's say in your laptop, right, you have limited storage up to, let's say, 1 TB or 2 TB, right? Or if you are using some high configuration computer, it's not going to be beyond 5 TB, right? So whatever data you are storing in your local machine, right, as there is a limitation of hardware for your local laptop and your local computer, you are going to get only limited storage, right? So if you want to store, let's say, petabytes of data or exabytes of data, you will not be able to store into one single machine, right? You will need to distribute your data into multiple machines, right? Or you'll need to divide your data into multiple machines, and then you'll need to distribute across the different local systems, right? So you have a limited storage space available in your local file system. Along with the limited storage, right, you also have the limited processing power. So let's say in one single machine, right, you are getting only you can say some limited amount of processor, right? So right now the maximum processor that you are getting out of your laptop is the i7 only, right? So you cannot have like processor more than i7. Now let's say you want to process some large amount of data, right? Then that one processor might not be enough for processing your entire data set, right? When especially when you are dealing with the you can say hundreds of terabytes of data, or you can say hundreds of petabytes of data, right? And there might be a chance that if your processing logic is complicated, then there might be a chance like even like you cannot process gigabytes of data with the available processing power in your laptop. And even if you can process, it might take, you can say, the number of days, or you can say the number of hours for finishing that particular process, right? So again, that limited processing power within your local system is again one more drawback, right? Which we cannot work out like in the production environment system, or which we cannot work out to solve the big data problem, right? So limited storage space, limited processing power, right? Data sharing is again a problem, right? So you cannot share the data with anybody if you are not on the network, right? So let's say you are storing all your data into your local machine, right? And let's say you want to share it with somebody within your company, then as it is in your local machine, right? You cannot directly share that data. So what you will need to do is you can create one shared drive, and with the help of that shared drive, either you can share it, but again it's going to be time consuming. But in short, you cannot say like your data will be at the centralized location which can be accessible or which can be easily accessible by everybody, right? That's not the case in case of the local file system. And the major drawback that we are facing with the local file system is what is the data loss, right? Why data loss? So let's say in your local file system, right, whatever data you are having, you are storing into your one single system, or you can say one single computer. That may be your laptop, or that may be your some personal computer, right? Now let's say due to some hardware failure, or due to some software failure, right, or due to some hard drive crash, right, your machine goes down, right? You are losing all your data. So there is no way like you can retrieve your data back, right? And right now the data is the most important business for each and every company, right? So you cannot afford losing anyone's data, whether the data is important, or whether the data is less important, or whether the data is not important, right? But whatever data you are getting, right, you cannot afford losing that data at any cost. But if you are going to store that data within your local file system, right, then if there is only one copy of that data, and there is that too like within your system only, then if your system is facing some issue due to some hardware failure or due to some software failure, then you are going to lose all your data, right? And it would be very difficult to retrieve that data back after once you are losing those data, right? So again, the data loss is the biggest challenge that you can say the biggest challenge with the local file system that people were facing in the market, right? So these are the you can say the drawbacks of the local file system, right? So like I said, the storage will be done in your local machine only. The processing will be also be done in your local machine. And like the storage and processing both are performed on your local machine, you are going to have the limited storage space, you are going to have the limited processing power, and data sharing is going to be a problem. And the biggest challenge that you'll be facing within your local file system is going to be your data loss. That means if something goes wrong with your machine, then your data will be completely lost, and you won't be able to retrieve those data back again, right? So that is about the local file system, right? Now coming back to the distributed file system, right? So distributed file system was the distributed file system came into picture to overcome the drawback of the local file system, right? So there were two concepts, right? One is the distributed file system, right? So the distributed file system is mainly for the storage, right? And another one is the parallel processing, right? So that is mainly for the processing, right? Now what do you mean by distributed file system, right? So if you'll compare this distributed file system with the Hadoop, right? So distributed file system is DFS, and your Hadoop is HDFS, right? So they have just used the concept of the distributed file system in Hadoop. They have optimized that concept, and then they made it like Hadoop, right? So you can call like distributed file system is the you can say unoptimized version of the Hadoop, or you can say the HDFS, right? But the concept behind the distributed file system and the concept behind the Hadoop both are like, let's say, almost similar. But whatever drawbacks were there within the distributed file systems, the Hadoop has like overcome those drawbacks, and they are like providing foolproof solution for performing like, or for you can say executing your for storing your data and processing your data within the distributed file system, right? Now we'll understand the distributed file system only first, right? Because our main goal right now is not to focus on the HDFS, but we'll mainly focus on the DFS, right? So what is distributed file system, right? So let's say in your local file system, right, you were storing your data into one single machine. But coming to the distributed file system, right, rather than storing your data into one single machine, you will be storing your data into cluster of computers. That means, so let's say you have some computer 1, you have computer 2, you have computer 3, and let's say you have computer 4, right? Now let's say whenever you have multiple computers, right? So the concept of the distributed file system is nothing, right? But let's say integrate these computers all together, right? Prepare a cluster out of that computer, and whatever cluster is getting formed, use that entire cluster, right, to store your data, as well as use your entire cluster to process your data. Now what do you mean by a cluster? So cluster is nothing but cluster is the number of computers, or you can say the number of servers coming together, right? So that the processing power and the storage power of that particular machine will be shared among each other, right? So let's say here is my computer 1 is like you can say one of the node. I'm integrating with the computer 2, I'm integrating with the computer 3, right? And I'm integrating with the computer 4, right? So now let's say if my one PC or one computer is going to have, let's say, 1 TB of storage space, right? Why? Then, sorry, it's 1 TB, not 10 TB. Right. So let's say if my one computer is having 1 TB of storage space, right? So my total storage will become what? 4 TB, right? So I should be able to store, let's say, 4 TB of data on top of this computer, right? Similar to that, let's say if my one computer is having like i7 processor, right? So my total processing power are going to be i7 into 4, right? Now let's say with the help of the distributed computing, right, I will be able to store 4 TB of data, rather than like I was able to store just 1 TB of data in my local machine. Similar to that, let's say if I'm executing one process on one computer in my local file system using i7 processor, if that process is taking, let's say, somewhere around 4 hours, right? If I'll be executing the same process on the distributed file system, right, as there are 4 processors, those 4 processes will be distributed among like different computers, and with the help of that it will be able to finish processing within what, 1 hour of time, right? So that is nothing but what? Parallel processing, right? So parallel processing is nothing but whatever I'm sorry, So whatever number of computers you are having or whatever number of nodes you are having within your cluster, right? Utilize that cluster to parallelly process your data. So that means, let's say here we have 4 node computer, right? So we'll be utilizing all 4 computers for processing our data. So let's say if we have 4 process, like each and every processor will be getting one process, right? And let's say they'll start executing those executing your data parallelly. And if, like, let's say one earlier one processor was taking 4 hours, then as these 4 processors will be working together, you'll be able to finish your processing within what, 1 hour. And similar to that, like for storage, right? As earlier only one computer was there which was able to store just 1 TB of or 1 terabytes of data, but right now, right, it will be able to store, you can say, 4 TB of data, because you have like 4 different computers which you have connected together, so that its memory and processing power will be shared, right? So that it will be able to store, you can say, the 4 terabytes of data, like it was earlier able to just store what, 1 terabytes of data, right? So that's all about like distributed computing, right? Now, or you can say the distributed file system. We'll be understanding the drawbacks of the distributed file system. So the first most drawback that we are facing is locking mechanism, right? So now, what do you mean by locking mechanism, right? So let's say whenever you are working in a distributed environment, right? So let's say here is your distributed environment which has, let's say, 4 computers. Now, it's not necessary like all 4 computers will be used by only one single person, right? So let's say for each and every computer you have different users. So let's say here you have, let's say, user 1, here you have user 2, here you have, let's say, user 3, here you have, let's say, user 4, right? Now let's say there are 4 different users working on the distributed computer, or you can say the distributed file system. Now the advantage of the distributed file system is, so let's say if you are user 1 working out of computer 1, right? So as you are working in this distributed environment, you will be able to access the files which are stored on the user 2 computer, user 3 computer, user 4 computer, right? So let's say if you have some file A available over here, then this file, or you can say this particular file, will be accessible by all the users. So if user 1 wants to make some modification on top of this file, or if he wants to read that, he can do that. If user 2 wants to modify this file, he can do that. If user 3 wants to modify this file, he can do that. Or if user 4 wants to modify this file, he can do that, right? So now, what do you mean by locking mechanism? So let's say you have user 1. So user 1 is opening one file, that is nothing but your file A, which is stored on the user, you can say, user 2 computer, right? Now he is trying to modifying the file. So let's say the time duration for that particular is somewhere around, let's say, 12 o'clock 01 second. He is opening the file, right? 12:00:03 second, he's trying to modify the file. Now you have, let's say, some user 3 who is also opening the same file at the same time. Right? So now let's say user 1 is modifying the same file, user 3 is modifying the same file. Now let's say this is your file A, which has some content like, so this, which has, let's say, file A is having these 3 different lines. So hello world, how are you, right? And this file is stored in the distributed file system. Now user 1 is opening the file at, let's say, 12:00:01, right? And he's modifying, he'll start modifying the file from 12:00:03, right? And at the same time, user 3 is also opening the same file, right? And he's also start modifying the file. So let's say the modification has, like, let's say, modification by user 1, right? So user 1 will also, so let's say this is your line number 1, 2, 3, and let's say 4. So user 1 will start writing his content from line number 4, Similar to that, as user 3 is also opening the file at the same time, right? He will not be able to see this modification until and unless user 1 will commit his changes, or you can say user 1 will save his changes. So user 2 will also start writing from the line 4 only. User 3. So now what will happen is like, so as both the users are modifying the same file from the same line at the same time, right, at the end, nobody will be able to save their content, or nobody will be able to save their data, right? And because of that, your file will become the corrupted one. So what locking mechanism is telling you is like, so let's say when in a distributed file system or in a distributed environment, whenever one user is accessing the file into write mode, right? That means if let's say user 1 is opening this file in a write mode, that means if you want to write some content in that file, or if you want to modify the content of that file, you should not allow any other user to open that same file into write mode. Let's say that means you should not allow user 3 to open that same file into write mode. If user 3 wants to read that file, he can read that, because read is not going to harm your file, or read is not going to harm your content, right? But if both of them will start writing the data, or both of them will start writing the content from the same line, then it's going to harm your file, it's going to corrupt your file. So you should not allow two users at the same time for writing into the same file. One user can write, while if any other user wants, they can read, but two users cannot parallelly write. But in distributed file system, that was the drawback, right? That was the biggest challenge to maintain this kind of scenario into distributed environment. So that's why the locking mechanism was missing over there. And due to which, if like users are not aware, like other user is modifying the same file, right? So they will start writing the content, or they will start modifying the same file, and at the end nobody were able to save their data, and whatever efforts they were putting, they were like they were going useless, right? So that's about the locking mechanism. Then you have, let's say, metadata solution is not there. So what do you mean by a metadata solution, right? So metadata solution is nothing but, let's say, whenever you are having some data, or whenever you are having some file, right? So for each and every file, you have two different things. One is the metadata, and another thing is the actual data. Now, what do you mean by a metadata? So metadata is nothing but, you can say, it's a data about data, right? So the standard definition that we are giving about the metadata is nothing but it's what data about the data, right? So how you can get the metadata of the file, right? If I want to give you the example of the metadata, right? So data about data is just like a standard definition, but if I want to give you the proper definition of the metadata, or if I want to give you the example of the metadata, right? So let's say whenever you have some file, right? So whatever properties are there with respect to that file, that is going to be your metadata, right? And whatever content is there with respect to the file, right, then that is going to be your actual data, right? Now, what do you mean by properties? So let's say I have this file right now. I'll just save this file. So I'll just save, let's say, on desktop, right? I'll give you some name of the file as Hadoop career IT, right? I'll just save this file, right? And now I'll go to my desktop. So I have my file called Hadoop career IT, right? Now when I select this file, right click and click on the get info, right? So rather than get info, if you are on Windows, you can click on the properties, right? So when you right click on the file and when you click on the properties, right, so you are getting certain information. That the first most information that you are getting is what name of the file. So let's say the name of the file is the Hadoop career IT, right? Then size of the file, so the size of the file is what, 3 KB, right? Then you're getting the modified date and time. So let's say the modification was, let's say, today 7:28 a.m. IST, right? Then you are getting some other general information, like let's say the type of the file, that is your text edit document. So the size on the disk, then where your file is stored, when it was created, when it was modified, right? So all those informations you are getting when you'll right click on your properties, right? Plus you'll also get the permissions in Windows, like let's say, okay, whether you have only read permission, whether you have write permission, or whether you have append permission, right? So whenever you right click on the file, see the properties, right? And whatever information you are getting, that is name of the file, type of the file, size of the file, read write permission, location, created date and time, modification date and time, then all those informations are nothing but, you can call those information as the metadata, right? But whenever you open that file, so let's say I'm opening that file, and whatever content is written inside that file, so let's say this is all my content that I have written, that is called as what, your actual data of the file, right? So there is the difference between metadata and the actual data, right? So the properties of the file is metadata and the content is what, actual data, right? So now let's say whenever you are storing your data into distributed file system, there should be some centralized location which should be containing all the information regarding your file. So let's say I have this scenario, right, where you have, let's say, computer 1, 2, 3, and 4, right? But in this case, right, each and every computer is having its own information only, right? But there is no master location, or there is no centralized location which is containing all the information. So let's say I can have, like, let's say, some master over here which is containing all the information, like which file is getting stored inside which node. So let's say master should be having the information about all the files inside user 1, or you can say computer 1, all the file inside computer 2, all the file inside computer 3, and all the file inside computer 4, right? If master is containing those kind of information, then whatever request you want to process, you can directly send that request to master. Then master should be able to take care of like all the request coming from the user, whether it's for reading or whether it's for the writing, right? So this kind of scenario is like missing in the distributed file system, right? So that's why it's not providing the metadata level solution at the centralized location, and each and every computer will be having like its own metadata information, right? Then it will not divide and distribute your data, right? That means let's say whenever you want to store your data in your distributed file system, right? So let's say here, right, you want to store your data in this distributed file system. So you have 4 different computers starting from computer 1 to computer 4, right? Each and every computer is having like 1 TB of storage. So that means you can store total 4 terabytes of data, but 4 terabytes of data in the chunks of one terabyte, right? But let's say you have one file, right, which is, let's say, somewhere around calling file X, right? And the size of that file is, let's say, 4 TB. Will you be able to store this data, or will you be able to store this file directly on this distributed file system? The answer is no, right? Though you have the total storage space of your distributed file system is 4 TB, but that 4 TB is in the chunks of what, 1 terabyte. So if you want to store this 4 terabytes of file within your distributed file system, that means you will need to divide this file into what, 4 chunks of 1 TB, right? And after dividing like 4 chunks of 1 TB, you'll be able to place 1 TB over here, 1 TB here, 1 TB here, and one more TB over here, right? So with that, though you have like distributed file system with, you can say, the larger storage space, right? But distributed file system is not capable of you can say divide and distribute your data. So divide is nothing but dividing this 4 TB into the chunks of, like, let's say, 1 TB, and distribute it across your distributed file system. So distributed file system is not capable of doing or performing those kind of operations, right? So that's like one more drawback, right? And again, it will not be merge your data for processing. That means, let's say, after you have divided your data, right, into 4 different chunks, right? If you want to again process that, so you need to process this as entire file, because you cannot process this like as a 1 TB of chunk, because you don't know which data will be residing at which location. So you will need to process it as a file. So at the time of processing, you need to again merge those data. So if you want to, like, let's say, merge that, right, you need to do it by yourself. Distributed file system is not capable of merging those data. So that's about the local file system and the distributed file system. Any questions so far in any one of that? Okay, no questions so far. Then we'll move forward to the RDBMS, right? So RDBMS is nothing but, you can say, your relational database management system, right? So all of you must have all of you must have worked with like any of the relational database management system, that may be your Oracle, MySQL, SQL Server, or you can say the MS Access or Postgres, Greenplum, right? So there are so many relational database management system solutions available in the market, and you must be dealing with the relational database management system on a daily basis, right? So the problem with the relational database management system is what, right? So the first most problem is like with the relational database management system is it can only handle structured data, right? So right now, right, as I mentioned earlier in our yesterday's session, right? So right now, the way the structured data is increasing, right, the amount of unstructured and the semi-structured data is increasing in a similar way, right? So the problem with the relational database management system is like it can only handle the structured data. So like if you want to store your data in forms of row, columns, and tables, right, then your RDBMS is like enough for you. You can use your RDBMS for storing and processing your data, right? But only and only what, structured data. But the moment you are thinking of like storing unstructured data or semi-structured data on top of your RDBMS, right, then it's of no use, right? RDBMS is not capable of storing your you can say unstructured data. The reason behind that is like the design, it is designed in such a way that it can only and only handle structured data, right? And that's the reason, right? More if you take the example of any of the traditional website or traditional system, right, which were working on the RDBMS, right? So let's say if you take example of any online application form where you are supposed to upload your photos, right? So like photo is like unstructured data, right? So as most of the traditional systems were dependent on the relational database management system, and it was not able to handle the unstructured data, right? So they were giving you the limited size of the photos, like you cannot upload the photo more than 10 KB or 15 KB or 20 KB, right? Because the backend system was not capable of handling, you can say, the large amount of unstructured data, right? So that's the reason, right? Like as most of the RDBMS system or most of the traditional systems were on top of RDBMS, right? The functioning of those systems were limited to just the structured data and not the semi-structured or the unstructured, right? Then it can only handle structured data. The another drawback is like it can not store large amount of data, right? So like in any of the RDBMS system, if you take, right, if your data is going beyond certain limit, right? So let's say you are storing some terabytes of data into some any of the relational database, so you have, let's say, some billions of record into one single table, right? So uh, whenever you'll start querying on top of that data, right, your query either will be getting timed out or your query will be taking like number of days for the execution, right? And in case of like big data world, right, we cannot wait for the number of days because we want to gain or we want to get like some competitive advantage out of that. So we cannot wait for the number of days like for query to get finished its execution, right? So if you are storing large amount of data on top of your RDBMS, right, so you can say you'll be getting like high latency query time, right? That means if you are storing large amount of data on top of your RDBMS system, then whatever queries, right, you are executing, right, it's going to take more time, right? That means it's going to take the high latency query time, right? So that's about the drawbacks of the RDBMS, and then we'll understand the drawbacks of the, sorry, NoSQL, right? So like NoSQL is the next generation database, right? So next generation database means like whatever data, right, that we are storing into the relational database management system, right? So NoSQL is the advanced version of the relational database management system. So advanced versions in sense of what, right? So in if you take the example of any of the relational database management system, right, so the problem with that is like all the relational database management systems is designed in a similar way. Similar way means what? So let's say you have the concept of database, you have the concept of table, you have the concept of normalization, then you have the concept of subquery, joins, union, intersect, everything, right? But coming to the NoSQL, right? So NoSQL itself stands for like not only SQL, right? That means like apart from whatever you are doing in a traditional SQL way, right? There is like much more other way to do the same thing, which we with the help of which you can optimize your performance, you can optimize your query timing, right? And you can store large amount of data as well as you can store as well as you can process the large amount of data in a you can say you can say low latency time, or you can say low latency query time, right? So NoSQL stands for not only SQL, but apart from doing your things into like traditional SQL way, right? You can like optimize those things with the NoSQL. And what they have done is like they also have the concept of database, they also have the concept of tables, right? But they have changed some terminologies. And apart from that, right, whichever SQL functionalities or whichever RDBMS functionalities which were taking more time, right, they have optimized those things. So let's say whenever you are performing joins on top of two tables in RDBMS, your query will take more time. Then NoSQL guys have like eliminated the joins. So you cannot perform joins on the NoSQL table, you cannot write the subquery, you cannot have the union, you cannot have the intersects, right? Because those things are taking more time. Then how you can achieve all those things, right? So again, the design has also been changed. So in relational database management system, right, so all of you must have used like the concept of normalization, and at least you must have like heard about the normalization concept, right? So normalization concept is nothing but you are normalizing your database in such a way, right? So the required information will be stored into one single table and remaining information will be moved to the next table, right? But coming to the NoSQL, right? So NoSQL itself allowing you, or NoSQL itself is telling you to store your data into the denormalized format rather than storing into the normalized form, because joins are not joins are not getting performed, or joins are not getting allowed, subqueries are not getting allowed. So whatever information you want, just store all those information into one single table, and NoSQL will guarantee you to you can say query on top of that table, though the table is large, but NoSQL will guarantee you to query on top of that table into like let's say minimum amount of time, right? So the drawbacks with the NoSQL is like it can only handle structured and semi-structured data, right? So like your SQL can only handle structured data, NoSQL can handle both structured as well as semi-structured, but unstructured it cannot handle, right? And another thing, right, only one of you can say there is only one drawback, right? But you have like few advantage for this one is like, so it can handle petabytes of data, right? So NoSQL itself is capable of handling petabytes of data. So if you want to store petabytes of data on top of your NoSQL database, that may be your HBase, Cassandra, MongoDB, right? Then you can directly store it on top of your NoSQL database, right? And if, yeah, one more thing, if your data is going beyond petabytes, right? So each and every NoSQL database is providing you the functionality for integrating it with Hadoop, right? And once you are integrating with Hadoop, right, you can also store the data beyond petabytes, right? And another advantage is like for large data set as well, query will get executed in low latency, right? So if you are performing, you can say your query on top of large data sets or terabytes of data sets or petabytes of data sets, right? Whatever query you are executing on top of your NoSQL database, your query is going to take minimum amount of time. So it's not like it's not like SQL, or you can say the RDBMS, right, where your query will be taking more time if your data is going beyond certain limit. But in NoSQL, right, even if your query is going beyond certain limit, right, your even if your query is going beyond certain limit, right, you can say your query will take a like minimum amount of time for the execution. So yep, that's all about the traditional system available, or you can say the existing system which were available in the market. So starting from the local file system, right, distributed file system, RDBMS, and the NoSQL. Any questions out of that? Okay, if there are no questions, then now we'll move towards the Hadoop, right? So why Hadoop came into picture, right? So whatever drawbacks were there in the existing systems, right? So if we'll start with the local file system and we'll go till the NoSQL, right? So whatever drawbacks were there in the existing file system, right? To overcome those drawbacks, Hadoop came into picture, right? So here, right, in your local file system, your first most drawback is what? Limited storage, right? So coming to the Hadoop, right, you have what? Unlimited storage, right? So unlimited storage means what? So basically, why Hadoop is popular, right? So Hadoop is popular because of its clustered nature. So clustered nature means, so Hadoop is not meant for executing, or you can say the storing and processing your data into one single machine, but rather than that, you will be creating a cluster of computer with the help of the Hadoop. So that cluster may be of, you can say, the different size based on your requirement. So let's say if you have, let's say, one computer which is capable of storing, let's say, 1 terabytes of data, which is having i7 processor and 16 GB of RAM, and if you are creating a cluster of, you can say, similar 10 computers, then your total storage will become what? 10 TB, right? You will be able to store you'll be able to store 10 TB of data. Your memory will become like 16 GB into 10, and similar to that, your processing power will also become what? i7 into 16. Sorry, i7 into 10, right? So with that, right, you are getting unlimited storage. Let's say that if that 10 GB is not enough for you, or your 10 terabyte of storage is not enough for you, then at runtime you can add any number of nodes in your Hadoop cluster, or you can say any number of extra computers you want to add in your Hadoop cluster at any point of given time, right? So your storage will by default automatically get increased. And similar to that, if let's say you don't need, like, let's say, a node out of your cluster. So yeah, right now you have, let's say, 10 node cluster, but if you are thinking like all those 10 nodes are not getting utilized effectively, or all those 10 nodes are not getting utilized properly, then if you want to decrease the size, or if you want to remove any node out of the cluster, then you can also remove it at any point of given time, right? So that is going to be, you can say, an advantage of Hadoop. So you can have unlimited storage based on the requirement. You can increase or decrease the number of nodes inside your cluster at any point of given time. If you are increasing the node, the storage will increase as well as the processing power will be increased. And if you are decreasing the node, the storage will decrease as well as the processing power will be decreasing, right? So similar to that unlimited storage, you also have the unlimited processing, because like I mentioned, right, if one computer is having like uh, you can set i7 processor, and if you are creating the 10 node cluster, then it's going to be your what? It's going to be your i7 into 10, right? So if, let's say, if you're executing 10 process into one machine, and if it's taking 10 hours, right, then if you're executing the same thing on top of your 10 node Hadoop cluster, right, each and every processor will pick one process, and you'll be able to finish your outcome, or you will be able to finish your process within what? 1 hour, right? So that is your unlimited processing. Then you have the another drawback is like data sharing. So data sharing is not a drawback, because in Hadoop, right, data is stored in a distributed way, right? So as your data is stored in a distributed manner, each and every person, or each and every user who is connected to your Hadoop cluster can easily access your data, can easily process your data based on his or her requirement, right? So data store, you can set the uh, data sharing is not an issue with that. The another drawback that you are having is what? Data loss. So again, in Hadoop you have the concept of replication. That means, so whatever files you are storing inside Hadoop, right? By default, Hadoop is maintaining 3 different copies of one single file. So as Hadoop is maintaining 3 different copies of one single file, right? You don't need to worry about the data loss, right? Why? Because let's say all the 3 copies will get stored into different machine, and if one machine goes down, you'll still be able to retrieve the data from another 2 machines that you have available inside your Hadoop cluster. So that is again an advantage of, you can say, this Hadoop, because replication is the key factor of Hadoop, where, as I stated earlier, right, data is more important than your storage space, right? Because right now the storage is cheaper, right? But if you lose your data, you lose your business. So if you want to gain competitive advantage, then you'll have to, you can say, you'll have to store your data in an effective way, and your data must not be lost, right? So that's an advantage of you can say the Hadoop, right? Now from the local file system, if we come to the distributed file system, then you have the drawbacks as like locking mechanism is not there. That means, as I stated, as I mentioned earlier, right? So if one user is accessing the file into write mode, you should not allow any other user to access the same file into same mode. But coming to Hadoop, right? So you have the locking mechanism. That means multiple user cannot access the same file into same mode, right? So you have the locking mechanism. The another drawback was another drawback with the distributed file system was like metadata solution is not there. So here you have metadata level solution, right? So Hadoop is following the master slave concept. That means you have one master and multiple slave, and one master will keep track of all the slaves. So let's say whatever files you are storing inside your Hadoop cluster, right? All the information will be stored, like what is the name of the file, type of the file, location of the file, read write permission, created date and time. All the metadata information will be stored on the master node. So whenever user wants to write some data in your Hadoop cluster, it will be directly requesting to the master node, and master node will be distributing the data across the slaves. And similar to that, whenever anyone want to read the data from the Hadoop, right? You can the request will directly go to the master node first, and then master node will be redirecting you to the slave node, like, okay, go ahead and read the file from this particular node, right? So that's an advantage. Then another drawback that you had is like it will not divide and distribute your data. So in Hadoop, right? So the data is getting stored in form of blocks. So it will divide and distribute your data. That means, let's say if you have, I gave you this example, right? So if you have, let's say, 4 terabytes of file, right? So Hadoop is storing the data in form of blocks, right? So let's say if you want to store your 4 terabytes of file in this environment where you have, like, let's say 4 different machines, each one is of like 1 TB, right? Then Hadoop will be like able to distribute this file into 1 TB of chunks based on your requirement. So you don't need to do anything. You'll just need to give, okay, I want to store this file, right, on this cluster, and you need to just give the name, give the path of the master node, and Hadoop will automatically divide this file into this 1 TB of chunks, and it will automatically store this data onto, you can say, these 4 different computers, right? So that's an advantage of the Hadoop. Like Hadoop will automatically divide and distribute your data across the cluster, and it will not be able to merge your data for processing, right? So coming to the Hadoop, right? So at the time of processing, Hadoop will merge all the blocks. That means whatever distribution it is doing in this step number 3, right? At the time of processing, Hadoop will be merge all the data, right? And it will be processing as one single file. So you don't need to do it anything by yourself. Whatever size of file you are having, whether one computer is having 1 TB of storage, or you can say 100 GB of storage, right? But let's say if you want to store that file into Hadoop, and let's say your file size is, let's say, 1 TB, 2 TB, or 10 TB, it's Hadoop's responsibility to divide and distribute your file across the network. And again, it's Hadoop's responsibility to, you can say, merge that file at the time of processing that data and process it sequentially one by one, right? So again, whatever drawbacks are there in the distributed file system, Hadoop is like resolving those drawbacks. And next you have the drawbacks of RDBMS, right? Like it can only handle structured data. But coming to the Hadoop, right? Hadoop is capable, it can handle structured, semi-structured, and unstructured data, right? So Hadoop is capable of storing all 3 types of data, which includes your structured data, which includes your semi-structured data, and which includes your unstructured data, right? So Hadoop can handle, or Hadoop can store all 3 kinds of data, starting from structured up to semi-structured and unstructured, right? And it cannot store large amount of data, but Hadoop is capable of storing large amount of data. So Hadoop is capable of storing large amount of data, right? And you can say with large amount of data as well, you will be getting low latency. That means whenever you are, though you have large amount of data, but when you want to retrieve that data, you will be able to retrieve that data with what? Low latency. That means you can say you can retrieve those data in a faster way, or you can retrieve your data effectively, right? So that's an advantage of the Hadoop. And if you compare with the NoSQL, right? So NoSQL itself is having a lot of advantage, but again here NoSQL can handle only structured and semi-structured, right? But Hadoop can handle, along with the structured and semi-structured, Hadoop can also handle what? Unstructured data. Right. So whatever the drawbacks were there in your existing system, starting from the local file system up to distributed file system, RDB maps, and NoSQL, right? Hadoop is capable of, you can say, solving or resolving all the drawbacks that you had in your existing file system, or you can say the existing systems available in the market. And that's the reason like Hadoop became popular, right? And one of the things that you will need to clear over here is like, here, right, you have local file system, distributed file system, RDBMS, and NoSQL, right? So here it's the combination of database plus file system, right? Coming to Hadoop, right? Hadoop is a file system, right? So most of the people are taking like Hadoop as the you can say the database, but Hadoop is not a database, right? It is a file system, right? It is not a database, right? And file system is nothing but like you have your C drive, D drive, E drive in your local computer, right? That is your file system. Hadoop is also a file system similar to that, right? Hadoop is not a database. So never confuse yourself with Hadoop, right? So most of the people are thinking Hadoop as the database, but Hadoop is not the database, right? Hadoop is storing all your data in form of files. So you can write the files, you can read the files, right? But Hadoop is directly not allowing you to query on top of those files. There are wrapper on top of that that we are going to cover. That is your Hive, your Pig, right? Which will be allowing you to query on top of whatever files you are storing inside your Hadoop. But make sure you understand it properly and you clear it properly, right? Hadoop is not a database; it is a file system. So all of you clear with that? Any questions? Yep. So that's it for like today's session. Right now, if you like anyone is having any questions with respect to today's session or with whatever we covered yesterday, right? Or any other questions, if anybody wants to cover, then I'll take those questions now. How Hadoop handles structured data, right? So Hadoop is handling structured data in form of files only, right? So whatever, let's say here is my, let's say one of the example that I gave you yesterday, right? So let's say here is my structured data, right? So this is my file, right? Okay, you mean to say unstructured data? Okay, so unstructured data is nothing, right? So let's say if I just say you in simple term, right? So in your computer, right, how you are storing your image or how you are storing your videos, you have like your C drive, D drive, right? Inside that you have your folder structure, right? And inside that folder you will be directly putting your image, right? Same thing for Hadoop, right? So Hadoop is a file system, right? Where you have inside that Hadoop file system you have different folder structure, and you can put your file in whatever whichever folder you want. So as it is not the database, right, it is very much easy to understand. It is storing your unstructured data in a similar way like your local machine is storing. Yep. Any other questions? Okay, so like I would take it as no. In that case, we can stop for today. Okay, guys, have a nice day ahead, and see you tomorrow. Bye bye.